All right, thanks, Mark. So what I want to do with the talk today is I want to sort of maybe take the talks that Rob Wheeler and James Hunt did on their wheat yesterday and roll them into one discussion today about canola, and maybe incorporate some of the same ideas that they talked about yesterday and that. And also just maybe touch on some of the stuff that Malcolm did early from his first presentation yesterday about the Canadian experience with canola, and maybe relate that back to what's happening in Australia. So for a start, just to lay the scene, because I'm going to be talking a lot about varieties when I get to the agronomy session, I thought it might be useful just to talk about what happened in NVT trials last year, and so then that lay the platform for some of the discussion we'll have a bit later on about times of sowing and some of the other tactical agronomy things that we can do with canola. So I'm going to run through the NVT stuff fairly quickly. But just to set the scene a bit, yesterday Malcolm would have been discussing that the Canadians over the last decade have improved their canola productivity by a bit over 4%. In Australia, this is a graph that John Kirkegaard put together. You can see over the last few years, this is the yield tonnes per hectare. Just because of the sheer nature of our variable climate, our canola yield does jump up and down a bit. And that adds, I guess, risk to our canola crop, and probably why we haven't seen those big gains that the Canadians have. The best guess in our increase in our canola productivity, if you sort of draw a straight line through that, is we're probably aiming for about 2% compared to the Canadians' 4%. So there's a lot of scope that we can use, learn from the Canadian experience and incorporate into the way we grow canola in Australia, and improve our productivity as well. But just factoring in this high risk that we've got in Australia. So let's talk about canola, the NVT results from South Australia last year. So this is just to lay the framework for all of the sites. This is the site mean yield of all of the Clearfield, just as a benchmark. All the Clearfield trials across South Australia. Pretty much the trials on Lower Eyre Peninsula yielded a bit over 2 tonne. Lock was a little bit harder last year, just struggled to get to 1 tonne. In God's own country at Minnipa, they cracked 1.6 or something like that. Fantastic year for growing canola in that drier environment. And even through this Yorke Peninsula and Mid-North region, where a lot of guys had a lot of trouble getting decent canola yields last year, the trials that John and his group put in through the Mid-North and Yorke Peninsula all yielded somewhere between 2.2 tonnes and up to 2.6. So we didn't see, in the NVT trials and the results that we're going to present now, we didn't see those really low yields that many growers experienced out in the field. And conversely, down in the southeast, Keith, we don't have any data for, not displayed here, but it was a tough year at Keith last year, and all of these southeast sites, the season broke about 2 or 3 weeks later. They didn't have the summer rain, and they had the dry finish that everyone else had. So you can see that the yields didn't go quite as well down that part of the world, and at Keith, a couple of frosts really topped the trial off, and we didn't release the results. So with that framework in mind, let's go through some of the... So this is the conventionals. Garnet, I'm going to rip through these fairly quickly. Garnet was a bit below average last year. Zircon, which performed very similarly, but interestingly, it's a little bit later flowering, and you can see those sites that really struggled at Keith and at Lock, it performed a little bit worse, so that's just that later flowering bit, we think. Hyola 50 performed quite well. The really good success story in the conventionals last year was New Seed Diamond. It's a hybrid variety, and it flowers probably as quick as anything we've got in the NVT trials, even about a week quicker than Stingray we saw at a couple of sites last year. And that liked the conditions, particularly in these lower yielding sites at Keith and Lock, did really well. So I'm just going to, then I just added Victory, which is a speciality type oil type that Cargill got out there. Some agronomists are using it as maybe as a different tool to manage the blackleg in areas, and that's about the Garnet type yield. So let's look at the long-term conventional yields. Garnet's about there, a bit above 105% at through most of the regions. Zircon's almost similar. The really productive variety over a number of years now is Hyola 50 in that conventional set. And we've only got a couple of data points for diamond on Lower Eyre Peninsula in the southeast, and it seems to be the long-term data suggesting that it should be there or thereabouts to what Hyola 50 is. So let's move on to the Clearfields. Hyola 474. Now, just an interesting thing to note about all NVT trials, the breeders nominate where each variety goes, and so you won't see a data point for every particular point because the breeders haven't necessarily entered it in those trials. So for the trials that 474 was entered in, did pretty well, slightly above average most sites. And you'll see when you put 575 on it, track pretty much the same. Slightly late, theoretically a slightly later flowering variety, and performed a little bit, relatively performed a little bit worse in the southeast where things were a bit tougher last year. And then again, if you go to that slightly later, again variety 577, struggled a little bit on Lower Eyre Peninsula, and it was a little bit worse down at Bordertown, but the further south you went, it went all right. So I'll just bring that one up again. 44 Y87 performed pretty well at pretty much all of the sites. No exceptionally good results, no exceptionally bad results. The new guy and the new kid on the block, 44 Y89, it's a new release from Pioneer. Flowers probably 3 or 4 days earlier than the 87 variety that we just flicked up there. Potentially just a little bit shorter in stature. That yielded really well at just about every site where we had it. And 88, which is the later variety in the Pioneer suite of varieties, did about average throughout the state. So let's just look at the Clearfield long-term stuff. 474 seems to get better the further east you go in the state for some reason or another. 575 is similar, with even higher benefit in the southeast. 577, similar again, and that reflects a lot of what we've been saying over the last few years with these Clearfields. If you're going to be targeting a yield of about 1.5 tons, you can throw almost a blanket over a lot of these varieties. This is 87. That's tending to yield a little bit better consistently right across a number of environments in the state. We don't have as much information on 89 yet, but it's in the mid-north and the southeast where we do have enough data to form a long-term average. It seems to be performing better than 87 there, and maybe not quite as good in the southeast. And the one variety that, probably because of the range of seasons that we've had over the last few years, that has performed really well is 45 Y88. We'll talk a bit about some of those again when I come to the agronomy section. So TTs in 2014, let's just start with Bonito. Bonito had a bit of a fairly average year last year and struggled to reach 100% of the site average at most of the sites. Stingray did some interesting things at a number of sites. So Lock, where things got a bit drier, it really excelled there. Arthurton, where it was a really high yielding site, 2.6 tonnes, Stingray struggled to match what the other varieties were doing. But interestingly, at Turretfield, it performed really well there. So Stingray's got some really interesting characteristics and probably makes it a little bit different to evaluate compared to some of these other varieties. Wahoo, the longer season variety out of New Seed, struggled a bit. The longer season variety struggled a bit to keep tabs with everything else, particularly in the southeast. Hyola 450 at the few sites where we had it last year did quite well. The consistent performer across the whole state last year and probably for the last few years in terms of a TT variety in the NVT trials has been this Hyola 559. It's been a really consistent performer across a large number of sites and performing really well there. And the other newer kid on the block is Pax Hyola 650, slightly later season variety, but even though things were a bit tough down the southeast, it's performing relatively well there, well through the mid-north region, probably not quite as good on the lower EP. And just to finish off on the NVT stuff, we just talk about long-term TT yields. So this is Bonito. As we saw with the 2014 yields, pretty much tracks along that 100% of the site average yield. Interestingly enough, when you put Stingray, and I haven't put the low rainfall environments in this map because I analysed them separately, but just to give you an idea, Stingray typically performs consistently less across those environments. If you put the upper air peninsula one up there, it would they'd come a little bit closer together. I've included crusher. We didn't have it in NVT trials, but we've got a long-term average on there because a lot of guys kept seed. I thought I might just throw it in there, and it performs very similarly to Bonito. Hole of 450. Doing quite well, about 100% of average, so it's nothing too spectacular. Again, like I said, the consistent performer over the last few years has been Hyola 559, and that's again proven in the long-term averages, about 105% of the site mean right across all the environments in South Australia. 650, maybe suited to that slightly longer growing season in the southeast. Otherwise, it's pretty much the same level as 559. And I thought I'd just throw in the speciality type, the Manola 314, where we've got a long-term average. It does struggle to come up to quite to the site mean at the southeast and the mid-north, where we do have enough data for long-term averages. And yeah, even though these aren't the early season set, I thought I'd throw Pioneer Sturt in there just to show its relative yield to Stingray, because that's quite often what it gets compared to in those low rainfall environments. And they track reasonably similarly, with Sturt just being a fraction below Stingray in most of the South Australian environments that I got up there. So that's pretty much the NVT set in a nutshell. So last year, Diamond performed really well in the conventionals. 44Y89 performed really well in the Clearfields, and the 88 has performed quite well as a long-term average across South Australia. And in the TTs, we've seen Hyola 559 perform quite well, with 650 performing really well again. So out of that, you're seeing that pretty much the top performers across South Australia in the last couple of years are all hybrids. We haven't got a lot of open pollinated options left. So it makes some interesting choices for advisors and growers going forward on all of that. So hopefully what I'm going to do now is maybe paint some other framework about what we know about, what we're beginning to understand about some of these varieties, about their agronomy and their physiology, so that we can make a more informed decision about what we grow in what situation. So to do this, GRDC have funded a suite of projects across Australia, and the one that we're working on is this Eastern project. We're in cahoots with the New South Wales DPI, and we're performing a range of tactical agronomy type trials at a range of sites for the next 4.5 years. We're only 6 months into this project. And we've got the CSIRO team in Canberra, led by John Kirkegaard and Julianne Lilly, providing a lot of phenological backup and providing a greater understanding of the science in the tactical agronomy stuff that we're developing. So they're providing a backup there, and Therese is going to help do some of the modelling work based in Adelaide. Interestingly enough, there's another project that GRDC are funding over in the west that Mark Seymour is leading with DAFWA. They're about a year further into their project, and they're spending a lot of their time working on reducing the risk of growing canola in their more marginal areas. And so they've had a lot of success in reducing seeding rates of canola over there, and they are coming up with some really interesting data on how late you can apply N in the system so that they're not loading themselves up with too much risk. And if you want some further information on that, GRDC's got Mark's presentations online somewhere. And lastly, there is a high rainfall zone project that Penny Rivkin, out of whatever the Victorian Department are calling themselves this week, works for. We've got our group at Struan are doing some work south of Narracourt on this, and this work pretty much focuses on how adaptive and where to sow winter types, maybe doing some work on plant growth regulators, because you can get things to grow really high and bulky in that type of environment, and maybe even looking at some semi-dwarf types and other types that might be more adapted to the higher rainfall type of thing. So there's a big suite of canola agronomy work going right across the nation now. So we'll talk a little bit about our project now, and you can see there's a lot of people that work on it. Not all full-time, but just so that we've got a wide geographical spread across the state and across the borders. So the tactical agronomy stuff that we're looking at is we want to get a better understanding of what happens if we start to manipulate time of sowing. Also, what happens if we start to manipulate crop density. do we understand enough about the way canola grows and its phenology, its physiology, to make informed decisions about how we can manage the crop better? And maybe use that information to maybe manage nitrogen, sulphur and other nutritional aspects a little bit better. And also, taking into consideration what happens with frost. So that's what we're doing on the tactical agronomy side, and this is being backed up by CSIRO's modelling group, led by Julianne there. So they're trying to really understand what drives the canola plant through its development. Understanding we don't know a lot. You would have heard James Hunt yesterday talking, for those of you that went, talking about how they've got these near isogenic lines and they've isolated the genes and they understand a lot about the way that wheat starts to flower and all of these things. We don't understand that with canola. So this is some of the stuff that Julianne's starting to tease out. Understanding what vernalisation requirement is of different varieties, what the photo period requirement is, what the thermal time requirement is. And all of these things just come together in a package, and they start to tell us what different varieties of canola need to reach their maximum yield. And so, that's what the CSIRO team are doing in the project. So our hypothesis is really we want to be able to maximise water use efficiency of canola. And we want to be able to the way that we think we can do that the best is to sow canola in a reasonably early fashion, but we want to be able to match the flowering date with the optimum window. So with canola, we don't understand a lot about where frost, the timing and the damage, the level of damage that frost can have on a canola crop, but it does tend to happen, the most damage we think tends to happen when the pods are relatively small, the seed's reasonably green. If you get a frost around that time, it can do considerable damage, but there's been experiences where it's done a lot more, also done considerable damage quite late in the season as well. But so we want to have varieties that flower at the right time and have the flexibility to be able to match our environment. We also want to be able to produce as much water use is essentially growing as much biomass as you can, but having enough water still left in the system to be able to fill grain at the end of the season. So whether we need to do some other things, like managing sowing date, population or nitrogen, to make sure that we do get that maximised biomass production so that we can maximise yield in a dry finish. And one of the important things that we want to do as part of this project is to be able to identify situations where we shouldn't grow canola. We're working across the Mallee and the Upper Eyre Peninsula as part of this project. We want to be able to identify situations when you shouldn't sow, and so that we can reduce risk for growers in those type of environments. So let's talk a little bit about why early sowing improves water use efficiency, and this is some of the stuff that John Kirkegaard did as part of the Water Use Efficiency Initiative. So by just getting more water going through the plant as transpiration, you get less evaporation, and you stand a better chance of creating yield. You get more transpiration efficiency, you get deeper roots, you create more biomass, and providing you've still got enough moisture in the soil to finish, you create more yield potential. So in the early 2000s, John Kirkegaard and Mike Robinson did a study to actually parameterise canola and fit it into this APSM model so that we can work out how well it should yield across a wide number of environments. So they did about 40 field experiments over a few years to actually work out how efficient it was in producing. And typically, this study found that canola produces about 11 kilograms per millimetre of rainfall. But that extremes, it also, the lower end, the most inefficient end, he got a lot of answers around that 8 kilogram mark. But at the upper side, he found that he could consistently grow canola you could grow canola out of 15 kilograms per millimetre of rainfall. And typically, all of those ones along that top edge, this higher water use efficiency, were all sown in April. Not early April, but just in the mid to late April. So that was work done back in the early 2000s. So what's new? We've got new and more marginal canola growing in a whole heap of different environments than it was back then. We've got a lot more, like I was explaining, we've got a lot more, a wider suite of hybrids. Got some more herbicide options. Imis have really taken off since that was talked about. Maybe some more drought tolerance in some of the varieties we're seeing. Our farming systems have changed. You know, we're talking almost total no-till systems now with precision, which can be quite important when you're sowing a really small crop very close to the surface. But we've also got to consider that we've got more herbicide-resistant weeds and a whole heap of pests that like eating canola that we've never seen before. And there is a suggestion that we're getting less autumn rain and a lot more variable springs, and input costs are certainly a lot more expensive, but that's nothing new about that. So the other things that we're trying to package together as part of an early sowing package, as part of an early sowing program, and so that's the hypothesis that we went into this project with. We got slammed by a virus that seems to affect early sowing last year, which has confounded things, but we've still got some good data to help back up the story that we're trying to work with. So this is just some of these 5 data points were from a selected number of trials last year, where hybrids were sown early, and that's increased. You know, we've reduced our evaporation there from nearly 110 down to maybe 90. So we're putting more water through the plant and creating more increasing water use efficiency that way. And maybe that's the way of the future. So now that's the sort of the theory and a bit of a taste about what we learnt last year. I'll just go through some of the trials now and just explain a bit about what happened in some detail. So last year we had 3 sites as part of this GRDC funded optimising canola profitability at Yalana, at Hart and down at Lamoureux. And I also want to touch on a couple that Sagat funded, some other work that I'm doing on canola establishment that we do to a couple of similar-ish time of sowing things that all fit into the same sort of picture. So there's nothing new there. This is what happened in the 2014 season. So we had a fair bit of summer rainfall, so we went into the season with a good profile of soil moisture. We had a good early start. We had good warm conditions early, and where it was growing well, canola did grow well, and we had a bit of virus, it was a bit of a problem. Had some very harsh winter frosts in August and a dry finish to the season. So I was going to talk a bit about the Hart site first. So this is the last field walk, the crop walk that Hart had. I was there, I just took some photos on that day. You can see the first time of sowing is just about ready to come off. Second time of sowing just got a little bit of life left in it. That one there doesn't come up real well on the picture, but that's a winter type, Hyola 971. And that did struggle in this environment, and you'll see some results coming forward about that. And those just to show a bit of a contrast, there's the last 2 times of sowing. So one other thing is, I'm just going to put up some flowering data for all of the sites, because it really helps explain what went on at the sites. First thing to notice is the latest variety to flower was that winter type, Hyola 971. We didn't see a flower on it before the start of October. And in a season like last year, it just didn't work. And so growing winter types, even when you sow them in the middle of April, is certainly nothing that's going to fit in the more medium rainfall zones across South Australia. The other interesting thing that we saw with flowering date is that Hyola 575, which is usually we think of as a mid-season variety, matches up quite well. Sort of usually its maturity we think would be somewhere in between these 2 pioneer varieties. But it flowered when you sow it early, it flowered nearly 2 weeks before everything else. And so, 5 minutes? Okay. All right, so this is what we think was happening at that site. So this is some data that Rohan Brill did with exactly the same set of varieties in exactly the same, sown in exactly the same trial. Hyola 575, and this is the thermal time up this side. So thermal time is your maximum daily temperature and your minimum temperature divided by 2, and your temperature just accumulates from sowing time. And so regardless of when Hyola 575 was sown, it required exactly the same amount of thermal time before it started flowering. And Hyola 474 Hyola 44Y87 gradually decrease. So we think this guy here has got a bit of vernalisation and a bit of photo period requirement. This guy at 575 just relies totally on thermal period to make it flower. And so what does that mean? Is that you've got a variety that starts flowering here, starts developing pods here, you get frost, and then from the same time of sowing, Hyola 44Y87 starts flowering. And so this has been, all of these guys here have been wiped off with frost. And this is the yield data from Hart. And you can see that 575 struggled a bit when you sow it in this early type of window. You sow it in more the traditional type of window and you're probably up there all right. It yields quite well, and it yielded well over a fairly wide window last year at Hart. But to maximise yield, if you're going to sow it early, you need to switch to something else, to a 44Y88. So that was Hart. I'm going to flick through Yolanda because it tells exactly the same story. I just spent a little bit of time talking about Lamoureux. So Lamoureux, we were in the mallee, they were loaded up with a whole heap of soil moisture. You got an early break to the season, you think, wow, you grow half the farm to canola, no problems. Again, we saw a similar sort of thing with flowering. The 575 just flowered a few weeks earlier than everything else. But what we did also find is that probably because the way things developed in the mallee last year is this second time of sowing, which still in early May, we had this second time of sowing flowering at the end of August where it's starting to get into some warm weather. And so how that transpired into yield is pretty much you needed to be in this window here to have a crop. Anything after that was pretty much gone. And again, having this slightly later season variety seemed to dodge some frost events that they had in this environment. And then, Minipa, I'll just finish off with Minipa. We sowed some Stingray, very early variety, got it flowering then. And Minipa, very similar experience to what James was talking about yesterday, doesn't seem to get a lot of frosts. And so if you sow an early flowering variety in a frost-free environment, it yields absolutely really well. And so I guess the take-home message out of all of that is you've got to have if you're going to sow early, you need to understand a bit about the way the varieties are developing, and you need to have a really good understanding of your frost risk. I'll move through to some of the challenges that we think we're going to experience with some of this. So pests, sowing canola slightly earlier, you're sowing into a warmer environment, DBM become a bit of an issue, and all of these guys seem to hassle you. Certainly the virus is something that we need to consider as part of a package that we're developing in putting all of the results of this forward. Weed management can be a bit of a problem, but having a vigorous early sown crop can be quite effective in managing weeds too. And the establishment of a small seed in a fairly dry or marginal environment can be quite challenging, and that's part of the work that we're doing with the SAGAT project. So just as a way of wrapping it up, water use efficiency can be maximised by sowing early, and we're not talking about going ridiculously early. We're talking about just bringing sowing forward into maybe around the 20th of April, so that you can. It moves a whole sowing program that little bit earlier if conditions suit, and it lets you start sowing wheat at a more optimal time. But varietal selection needs to be considered when you start moving that little bit earlier, just so that you're getting something that matches up, so that you can dodge frosts and flower at the right time. So, thank you.